Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the scales of the universe and the different sizes and things that we will look at, starting with Earth and working our way out to the edge of the universe. So in a way, we're getting an overview of some of the things that can be talked about in this class. So let's look. What about our trip through the universe? Well, we can zip through everything. We don't have to worry about light speed or anything else. We can start with Earth and work our way out to the edge of the universe by looking at various objects. Now let's start with a common one here, and that is our Earth. And here is our Earth as seen from space. We can see the continents of Africa and Europe and part of Asia here as we examine our Earth, and Earth being known as the only planet in our solar system that currently has liquid water on its surface. Now, if we want to move a little further out, we see our Earth Moon system. Now, if we want to see the Earth and Moon system, this is to scale. So if we size the Earth down to what is shown here, then the moon would be this size, about a quarter the size of the Earth, and it would be this far away at perigee. Perigee is when it's closest, and this far away at apogee, when it's furthest from Earth. So a range of distance here, but the size and scale is exactly what we would expect. And again, what's in between this is all empty space. So there is nothing in between those. Now let's continue looking outward a little further. Let's look at our solar system. Now, it's hard to compare our solar system in terms of sizes, because what we see here we scale to our sun at this size, and the planets are all scaled. But what it does not do is give us any sense of the distances between them. So because the space is so empty, it is not that they are this close together. There is actually a vast space between the planets. So here we see that. Now, if we want to look at that vast distance, let's look at that here. Here are some of the terrestrial planets to scale. Now the sizes of the planets, and then we go out to the giant planets here. So we can get an idea of the scales of these. And then if we want to look to some of the further out objects, some of the objects out beyond Neptune, and that shows them to scale. And you can see how the inner and the outer planets are very small parts of our solar system as visualized in this animation. Now we can move out a little further out beyond our solar system, and let's look at the nearest objects, nearest stars. And here is a map chart showing the nearest stars to our sun. So our sun is here at the center, and we see that there labeled Sol. And here are all of the other stars around us. These are stars within 15 light years of Earth. And we can see that there are a couple dozen of them, Alpha Centauri being one prominent one, the nearest. But if you look, most of these are not the prominently named stars in the night sky. And that's because most of those bright stars are much further away, but are extremely bright. Many of the nearby stars are actually very faint stars and very difficult to see. But we can still, again, we're getting that sense of how empty things are, that we have these stars scattered about with a lot of empty space between them. We can move further out to our galaxy, and here we see that our galaxy with the sun's orbit labeled here. And then we can see some of the different spiral arms. Now here it makes our galaxy look very full and packed with material. However, we still have to consider that there is a lot of empty space within this, as we looked at that around each of those stars. So remember how much empty space there actually is. Our own galaxy about 120,000 light years across. Now, as we move further out, let's look at some other galaxies. And here we see our local group. There's our Milky Way, which is here in the center. And the next nearest large galaxy is the Andromeda galaxy over here on this side. And those are the two largest galaxies. But there are a lot of small galaxies that make this up as well. We see a few spiral, elliptical, and irregular type galaxies that are scattered around. And there are actually a few dozen galaxies within a couple of million light years. Very few of them are easy to see. The easy ones to see are Andromeda, the Milky Way, and then M33, which are the three largest galaxies. Many of these other ones are faint and hard to see. But again, look at the empty space. We saw our Milky Way galaxy, but then there's all these galaxies worth of space where there is essentially nothing. Now we can move out even further and let's look at some clusters of galaxy. This is the Virgo cluster of galaxies. So here we're seeing a much larger cluster, and in fact even just the central portion of that cluster. We can go out beyond that and look at the supercluster. So galaxies cluster. Now there's our local group. And we have the Virgo cluster over here that we looked at. But now we have all of these others as well, which are also part of our local super cluster of galaxies. So galaxies tend to cluster into groups, which cluster into even larger groups. And those large superclusters, that's not the end of it. Those large superclusters will cluster into filaments. So here is an example of looking at some of those filaments of structure in the universe as to where material is. So we're part of that Virgo cluster and then the supercluster. But even that, beyond that, clusters into filaments. And we have all of the material clustered around these filaments. Remember that all of that was very empty space. So the voids here are even emptier. These big, large, hollow voids that exist are very empty sections of space that don't even have the clusters and superclusters, let alone galaxies, that we've looked at before. So the whole idea really to get out of this is how empty space is. We can look at an example here is that if we were make the sun the size of a basketball, Earth would be about the size of a pea and would be nearly 100 feet away. The nearest star a few thousand kilometers away. So there is nothing in between these. You would have the few specks of dust around one basketball, and then thousands of kilometers away you would have a few specks of dust around another basketball. The rest of that is completely empty space. Space is very, very empty. So get an idea of how empty space here is here. Let's go ahead and finish up with our summary. And what we've looked at, we've started with the Earth and looked out to the great filaments of galaxies. And what we've seen is that the solar system and the universe are both very empty. So that concludes this lecture on the scales of the universe. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.